So, hi guys. My name is, you can just call me Lisa. No need for Dr. Lisa. Soon it's going to be Professor Lisa, though. And before we start, just one announcement. And I'm also going to say it in behalf of some other speakers. Although I'm a very intelligent woman, I have a certain limited brain capacity. English is my third language. So if I'm going to be saying something that might trigger anybody because it's not gender neutral, please cut me some slack, okay? Let's just focus on the technical stuff. So who am I? I'm many things. As you say in Russian, I'll definitely not die of humbleness. However, what's important today is that I have a PhD in computer science from University College London, which I finished a couple of years ago. And the topic was computational argumentation. Yeah, that's why I'm single, because I out-argue every man. And the last 2 years I spent traveling around Southeast Asia and mainly teaching Python online to bankers. Pay a lot of money. And, but I'm starting a full-time position as a professor at Nazarbayev University in Kazakhstan in a couple of months. And that's who I am. So the content of today's presentation is going to be, first of all, I'll introduce you to topic modeling very quickly. I assume, given that you're here, you already know what it is anyway. Then why this talk, why I decided to talk about topic modeling in the first place, the different topic modeling approaches covered during my talk, 4 use cases that I'm going to cover based on industry experience. Yes, I worked in industry for 1 single year and then I quit and off to Asia. And then an overview of the Python topic modeling libraries, the dataset that I used, why I chose this specific one about climate change policy documents. Then very briefly the implementation of each approach, the evaluation, the results for each use case, then the strengths and weaknesses of Top2vec and BERTopic, the main topic modeling libraries that I'm going to cover, and a conclusion. So what is topic modeling? It's an unsupervised machine learning technique to automatically identify themes or, well, topics, hence topic modeling, in very large data sets. So you can think about tweets, customer reviews, news articles, like literally anything in textual format. However, most of that corpora is not labeled, right? So hence unsupervised. So once we throw that data in a topic model, we can cluster this data, which might reveal hidden structure in unlabeled data. Right? So for example, think of news categorization, social media monitoring, customer feedback analysis, and legal documents as well. And traditionally, so probably what you've covered most likely at university if you study computer science or machine learning, most likely covered LDA, which is a probabilistic word count model. However, well, a lot has happened since the early 2000s, and today we're mainly using pre-trained language models, right, which can actually capture semantics, and take syntax into account, which LDA doesn't. So so whether you're a researcher, a data scientist, or just dealing with large text corpora, topic modeling can be of immense use to you. And today, maybe some of you will be disappointed. I've heard complaints that some were annoyed that some of the talks are very superficial. I'm going to cover out-of-the-box libraries, right? So because I want this talk also to be useful for those who maybe don't have that much Python experience, who can't code a topic model from scratch, for whom it's much easier just to import a library and use that library and know how to tweak it, okay? Also, I'm also not a software engineer, so this is also why I prefer out-of-the-box approaches. I know some people here, they code stuff from scratch. So, cool. So why this talk? Well, this talk was, I decided to give this talk because it's based on the very short time that I worked in industry. I worked on a project in legal tech, and I was hired because I suggested to use topic modeling during the interview, and the guy liked it, and hence he hired me, and we achieved really, really good results. One of our clients was DEFRA, which is the Department for Environment, Food and Rural Affairs in the UK. So I used to be based in London. And they wanted to know which parts of regulation address certain topics of interest. So for example, flooding. How, like, are there any regulations that deal with flooding? Are there any regulations that deal with air or water quality? Things like that. And yeah, and we used Top2vec. And as I said, we achieved great results. Therefore, I was really happy. However, BERTopic was already around during that time as well. But it didn't support certain features that we needed. We'll get there. Now it does, kind of. However, back then, also because it's industry, you know, we have deadlines. We needed to act fast. I never did a comparative analysis between Top2vec and BERTopic, and I thought now is the time. Why not do it, and why not give it as a PyCon talk? So yeah, LLM approaches using prompting will be not covered. Maybe next year. So that's already an idea for next year. Don't steal it from me. So. As I said, I'll cover 3 topic modeling approaches. The basic one, which is Latent Dirichlet Allocation, LDA, which was developed in the early 2000s, so over 20 years ago. And it assumes that documents are mixed topics, and topics are distributions over words. Yeah. So it works using co-occurrence statistics and outputs word clusters, like, for example, for topic A, government, policy, and election, and then topic B, game, score, and team. But because it uses a bag of word approach, right, it cannot capture, for example, synonyms. Yeah, so instead of, I don't know, let's say government would be misspelled, right? That would be a completely different vector. Hence, wouldn't be able, like, it would not probably occur in topic A. You get the point. So yeah, then Top2vec came along, which was developed in 2020. And originally it used Doc2vec, so it was developed before BERT. However, now it also supports BERT embeddings. And it finds dense areas in the corpus using HDB scan. And then it identifies the most representative words in each cluster or topic. Yeah? And it's fully automatic, so I forgot to mention for LDA, you need to predefine the number of topics. So for example, it's a hyperparameter of the model. You need to say, for example, I'm looking for 10 topics, and LDA will find 10 topics for you. So what's great about Top2vec and BERTopic is, well, because it's unlabeled data, you don't know how many topics there are. Also, as many as there are people, as many there will be opinions. There's no way you have a huge language corpus and that, you know, I give it to all of you to label. No way you all will find the same number of topics, right? Everybody will, yeah, cluster them or sort them a bit differently. So yeah, so in Top2vec, you don't need to provide this parameter. And same for BERTopic, so it was developed literally just a couple of months after Top2vec, and it uses sentence BERT embeddings also with HDB scan. However, it works a bit differently, so the clustering uses something called class-based TF-IDF to extract topic keywords. It's fully automatic, and it also comes with very interactive and nice visualizations. So it's literally, it's like a suite. So everything is in there. You don't need to use any other libraries, for example, for visualization. Okay, now let me talk about the use cases. So as I said, some of them were inspired by my work that I did for DEFRA. So for example, as I said, they wanted us to find similar documents. So let's say they already found some paragraphs. So sorry, for those who don't have a legal background. So in the regulations in the UK can be really, really long and cover many things. There is no regulation which is just about which addresses flooding. Yeah, most likely it's some sort of like climate change mitigation policy document, blah, and then there's like one chapter or one paragraph which addresses flooding. And so DEFRA already identified some regulations or some paragraphs within regulations that they found interesting, and then they wanted us to find similar ones, but not just by doing Control F, right, but by capturing a bit more semantics. So that's use case number one. Then classifying documents. So let's say you want to build, you have a website where people, let's take a very banal example, a news website. Yeah, and somebody publishes an article and you want it to be published under a certain category automatically without anybody having to label it. So once you're happy with your topic model, let's say you reviewed it, you're happy, it's about 30 topics. So basically, how good are those topics that you can then use supervised machine learning to train a classifier, which then can classify a new document according to those topics. Then real-time integration. So let's say you do have a topic model, you're happy with it, you got a few new documents, but you don't want to retrain the whole model. Yeah, also all those algorithms, they're non-deterministic, so they will always be a bit different when you retrain it. But let's say you're happy with the one that you retrained, you tuned it, you did a lot of preprocessing, you're absolutely happy, you absolutely don't want to retrain it. is it possible to insert a new document inside that model and just put it into a certain topic? And so, by the way, BERTopic in the past didn't allow that, and this is why we decided against using it. Now it does. And then dynamic topic modeling. So I never had to use it. But I'm going to cover it because BERTopic supports it. Top2vec doesn't. So dynamic topic modeling means that we can track how topics evolved over time. And yeah, this can obviously also be very interesting to see how policies, changed, how maybe the same topic, let's say in the early 2000s, used different words than we're using for the same topic now. So maybe back then we had one issue that people were interested in, and now they're talking about a different one. So yeah, so these are the 4 use cases, which, again, as I said, are industry inspired. So these are the 3 libraries. So for LDA, I'm using GenSim. Probably many of you might have heard of it because it's not just doing LDA, it does many things. Then Top2vec. It is not actively maintained. So yeah, we were talking about it yesterday. There are libraries that are unfortunately not maintained, but however, they're still very usable. So last time, so when was my project? It was 3 years ago. I downloaded Top2vec a couple of months ago when I started this research for this presentation. It still works perfectly fine. Like I didn't have to create like some really awkward, weird virtual environment with a very, with a very dodgy version of NumPy. Sorry. So yeah, everything worked out of the box perfectly fine. And then yeah, BERTopic is actively maintained. So I just checked GitHub. Like the last update was literally a couple of days ago. So why did I choose that data set? So yeah, because I wanted to take something similar. Which looks similar to what I've already worked with. However, I didn't want to take the regulations one. I wanted to work with something new. And this is inspired by some of my students that I supervised a couple of years ago when I was still working as a lecturer at UCL. So they used this data set by Biesberg et al., which is called the paper is called Machine Learning for Research on Climate Change Adaptation Policy Integration, an exploratory UK case study. And so, yeah, they created that data set. They scraped all policy documents classified as policy paper in PDF format from the website gov.uk. Then they handpicked 10 documents, each for adaptation, mitigation, and non-climate, so which didn't cover anything about climate. And the final database contained around 14,000 blocks of text, right, with around 4,000 labeled as adaptation, 5,500 as mitigation, and almost 4,500 as non-climate. So that's the data set that I've used. The data set is much bigger, but this is the labeled part. So the same guys, they also what my students did with their data set is they tried zero-shot learning. So there's also a lot of unlabeled data. I didn't consider that because I actually wanted to work with a smaller subset to not fry my computer, not to waste money on some virtual server somewhere. And because I actually also wanted the original labels so that I can compare, for example, LDA with 3 topics and see whether they're similar to the 3 predefined ones, pre-labeled ones. Implementation. So for LDA, I deleted stop words. That's for those maybe who are, I don't think we have any complete newbies here in NLP, but just in case. So stop words are words that don't contain any meaning. Yeah, which, for example, and, a, the, etc., because they will be in all sorts of documents, right? They don't provide us any information. So for algorithms that don't use, the word order, these words are completely useless. So this is why we're deleting them. So this is what I did for LDA. For Top2vec, you don't necessarily need to do it if you don't use embeddings, but Doc2vec, for embeddings, you can obviously keep the text as it is, because it is smart enough to not consider those. It can tell if certain words come up in all of the clusters, it just ignores them, but I still deleted it. Used the default Doc2vec, so I didn't use any BERT embeddings. And then also what I did, I merged some smaller topics into bigger ones. So if there were some topics with only like 10 documents, then I merged it into the bigger one, which was which was similar to that one, using cosine similarity. However, you can also use Top2vec supports hierarchical clustering. So what you could also do is you can kind of like check the hierarchy and then merge models together, which basically like are together in the graph, and then they fork and become smaller topics. For BERTopic, I didn't do any preprocessing, right, because it uses BERT embeddings, but I also merged smaller topics into bigger ones. So evaluation regarding, ease of use, quality, efficiency, flexibility, interpretability. So all of them are easy to use. I said that at the beginning of the talk. That was my idea, that I wanted to present you things that you can easily use without having to code a lot, or at least let's say not code a lot of complicated stuff, and maybe like do some pre-processing using pandas, deleting stop word, things like that, but not implement topic modeling from scratch. Then the quality of the topics. So for LDA, clearly you really need to experiment and tune it, because you just don't know how many topics there are. You basically just guess. So topics can be, especially if it's a big corpora and you use a small number of topics, let's say 2 or 3, they might be very, very random. Then for Top2vec and BERTopic, the topics are really good. They're different, but as I said earlier, they're like, if I give you guys a big corpora to label, everybody of you will come up with different topics as well. So basically what you just need to do is to sit down and manually evaluate it. But yeah, the topics that are generated, they're absolutely not random. Like, you can definitely see that the documents that are in one topic are very similar. Efficiency. So yeah, LDA only takes a couple of seconds to train. So it's very, very fast because it uses the bag of words approach. And for Top2vec and BERTopic, they're obviously slower. However, on the other hand, you have to do it once, and then you don't need to retrain very often, right? So doesn't really matter in my personal opinion. I mean, clearly if it would take days and a lot of GPU, that's one thing. But with a corpus like that, I could do it on my local machine without GPU. It took a couple of minutes. So yeah, we're not talking about hours or days. Efficiency. Sorry, quality of the topics, efficiency. Yeah, sorry, I got confused. So yeah, these two take longer to train. Flexibility. So LDA is not very flexible, right? It doesn't have any embedding support. So yeah, all you can do is just choosing the type of preprocessing that you do. Top2vec now, as I said at the beginning, the original algorithm is based on Doc2vec, but now you can also, just from Hugging Face, import BERT embeddings that you want and insert them into Top2vec. And BERTopic is super customizable. Interpretability, I think all of them are very, when I was looking at it, at least in this data set, all the topics are very easy to interpret because all of those models, they give you the top words, right? I mean, you can check out all the words, but they have functions where you can just check out, for example, the top 50 words in Top2vec's case, for example, and then you can just see what topics are represented with each word. Sorry, with which words each topic is represented. So yeah, so interpretability, and LDA is of course super easy to interpret because it's a probabilistic model. The others you could argue, well, yeah, but we don't know how those decisions are made. They use UMAP or HDB scan. However, if you then actually look at the topic words, in my personal opinion, they were easy to interpret. I wasn't surprised why those algorithms or those black boxes decided on those topics. Okay, results. So for LDA, finding similar documents works ridiculously poorly. Why? Because each vector of a topic is a vector of probabilities. Yeah, so if you only have 3 topics, then you can see, as an example, one of the a document would be just represented with 3 numbers on how likely it is to be in that topic. And well, just with 3 numbers, using something like Euclidean distance or cosine similarity, it will not give you any super similar documents. I mean, I think it's kind of self-explanatory. Yeah, and then as I said, it uses a bag of words, hence ignores word order, semantics, syntax, etc. So yeah, for example, the use case that I gave you for DEFRA, who already had some documents they were interested in, wanted to find similar ones, LDA would have been a complete disaster, not recommended. So Top2vec works really well. So as I said, I actually used that one for that client. What is also really nice with Top2vec is that it saves the document embeddings, and BERTopic in the past didn't do it. I think maybe you could also have done it explicitly, so this is also what I've done now. They also, BERTopic still doesn't do it automatically, we'll get back to that. But with Top2vec, it's super nice, saves the embeddings after training, so you can very, very, very easily compare similarity of new documents to documents used during training, right? So let's say, a new policy document comes out. I want to know which ones are similar. I can easily just use cosine similarity and get the most similar documents. So same with BERTopic, but as I say, the BERTopic does not save document embedding. So basically, again, as I said, if you then host it somewhere on a server, you train it once, it doesn't matter how long it takes, and then you save the embeddings also, but you need to do two things. In Top2vec, you don't need to do it. You train the model and you have the embeddings. Whereas with BERTopic, you need to train the model, and then again, using that model, you need to embed the documents, which is super annoying, so it takes like twice as long. But it's doable. Like, it's just an additional step. Cool. Use case number 2, that was for classification. So with LDA, I just played around, right? I played around with LDA 3 because there were initially 3 topics. And you can see then, and then I just trained some out-of-the-box scikit-learn classifiers. Like, I'm sorry, guys, I couldn't be bothered to do something super fancy. So just using scikit-learn, logistic regression, SVM, random forest, KNN, XGBoost, and an MLP. And you can see the accuracies, especially for logistic regression and MLP, for 3 topics are quite high. So I also checked how overlapping they were regarding non-climate change, adaptation, mitigation. Not so much, but when I actually used those ones for classification, it also worked fine. So either whether you use the predefined ones or LDA3, you can see we get accuracy up to 92, and I didn't do any fancy tuning. I'm sure, you know, by better preprocessing, actually bother tuning it, etc. You could have gotten even better results. But then you see it starts declining. So for LDA 5, it already declined a bit, and then if you do something like LDA 50, yeah, the results are really not that great, which is not super surprising. I mean, 50 topics is a lot of topics, but yeah, unfortunately, quite often in such corpora, this is how many topics there actually are. So for Top2vec and BERTopic, can't remember no, I can. So because it's a non-deterministic model, I always got different results for different runs. However, it was always around the number of 70. So in this specific corpus, Top2vec and BERTopic, by the way, as well, they always found around 70 topics, something between 65 and 75. But as I said, if some super small topics are merged into bigger ones, including for, well, especially for use case 2, right? Because if you just have a topic with, 10 documents, probably classification is not going to work really well. And yeah, you can see that it definitely, the accuracies are, sorry, it's not accuracies, advanced scores. The advanced scores are higher than for LDA. They're not that great though. But as I said before, it really, like, I don't like saying it, but it depends, right? So it depends on your use case, it depends on your case, on your product. If it was something like a news website, obviously 50 topics is too much. Like, you wouldn't want to classify documents into 50 different topics. However, for what I said earlier, you know, when like for use case 1, right, where, you know, people didn't care about how many topics, they were just interested in, you know, similar documents, or in which topic did that document end up with. I want to analyze that topic closer. Maybe there are like other documents we haven't heard of yet. So here, maybe the more the better. Whereas for classification, I would probably recommend to reduce the number of topics. For BERTopic, there was one big issue, that it contained a huge class with the label -1, which means outliers. So I included it for the classification, I included it like a class. It was massive, it was like 1/3 of the documents. And I did a bit of research on how to fix that. Basically, you need to tune HDB scan. So BERTopic seems, you know, you need, although it is well maintained, and although, you know, it uses embeddings and stuff, and uses also similar clustering algorithms like Top2vec, including HDB scan. Top2vec also uses HDB scan, but we don't end up with a massive outlier class or topic, whereas in BERTopic you do. So unfortunately, if it's about using things out of the box, I would rather go for Top2vec than BERTopic, which you then still somehow need to tune. So yeah, also, which was surprising, is that I told you I didn't delete stop words, right? Because I was using embeddings. But it actually created some clusters where the most representative words were a, the, etc. So again, of course, it's not necessarily a fault of BERTopic. Maybe again, it's not my data set, and I also didn't go through 14,000 documents. Maybe there were indeed some paragraphs or some documents which really just contained a few sentences and didn't contain any interesting words. So yeah, Real-time integration, LDA doesn't support it. Top2vec does support it without having to retrain the whole model. And BERTopic, as I mentioned before, also supports it now, didn't in the past though. So as I said before, if you'd have a model, you're happy with it. If you want to insert a new document into it, works for Top2vec and BERTopic. And finally, dynamic topic modeling, LDA, Top2vec don't support it. BERTopic does. So again, if you have a use case where you actually want to do dynamic topic modeling, BERTopic is the way to go. Then no need to waste your time with the other. Well, no need to waste your time with LDA in the first place. That's outdated. We're not using that anymore. That was just for demonstration purposes. So very quickly, for those who have never heard of it, what is dynamic topic modeling? So it's a collection of techniques to analyze the evolution of topics over time. And so BERTopic allows DTM by calculating the topic representation at each time step. So again, clearly you need documents that have a time step attached to it, right? So in my case, I did, because those regulations, they were or like those policy documents were published in a certain year. So that was included in the data set, otherwise I could have easily found it online. So I did have in Pandas, I did have a column with the year. And so BERTopic, it, as I said, calculates a topic representation at each time step, and we don't need to run the entire model several times. Right? So how it works is that there is first an initial model fitting without any time steps, and then it splits the data set on time steps by applying C, TF, IDF to each subset of documents. Yeah, and then for each time step, a specific topic representation is generated. So it's the same topic, but for each time step, the representation for that topic differs. And so this allows you to, first of all, track the frequency of topics over time. So this is the graph that you saw here, which you could argue, that's not that difficult. I mean, that's just, just counting, the year. However, it also allows you, I mean, I specifically didn't do it, but it allows you to analyze the evolution of topic representations, right? So in the same topic, what did people talk about in that topic in 2012 compared to, for example, 2020? So BERTopic allows you to do that. So yeah, a very quick comparison. BERTopic might be a bit more interpretable. It, however, as I said, it has many outliers. But it has good visualizations, it supports DTM, it's highly modular, and it returns, in my personal opinion, from what I saw with this data set, it returns more similar documents than Top2vec. But be aware that I used Doc2vec and not BERT embeddings. But BERTopic, yeah, for use case number 1, it worked like really, really well. And BERTopic is better maintained. So really depends on your use case what to use. Both libraries come with their pros and cons. So conclusion, what is better? It depends. But what I want to tell you also, like from my personal experience, a lot of pre-processing is always necessary. Like there's no way you will just have your database, you will run it through a model and you'll get amazing results. Under absolutely no circumstances. So I actually spent way more time, but I mean, it's just data science 101. You build like cool models maybe 10% of the time, and like 90% of the time you like get data and clean it. So I had to do a lot of pre-processing. So for example, given it was, so not in this case, but for the legal tech project, right? Because it was actually actual regulations. They had a lot of legal lingo. So these are actually also stop words, right? Although there might be like, it's not a and the and like pronouns or whatever, but for example, the word preamble or abstract or things like that, right? So you need to do a lot of pre-processing always. So don't think that you can just build an amazing topic model in a couple of hours. That won't work. Then of course a lot of experimenting is necessary. So you actually need to go into each topic and check it out and, and actually think about it. So you still need to manually evaluate and actually check out like what the model spit out. Then, yeah, I always recommend merging topics, and then again, you need to experiment in which way you want to do it. Do you want to do it according to similarity, or do you want to do it according to hierarchy? Again, you need to experiment. I can't give you an answer to that. Then, of course, for DTM, only BERTopic, because Top2vec doesn't support it. And so yeah, here a few use cases / examples when I would use either one or the other. So for dashboarding and things like that, because BERTopic, I'm pretty sure it's Plotly because they're all dynamic and pretty and interactive. So yeah, for dashboarding, I would use BERTopic. Same, well, then of course for topic evolution and dynamic insights, whereas for things like a search engine, similarity retrieval, and just very fast prototyping, I would use Top2vec. So these are just my personal conclusions. And that's it. Thank you very much.
So, thank you, Lisa. we have some time for questions. That's good because we have many questions in Slido.
No.
So, and let's start with the first one. Yeah. How do these methods perform on short documents such as tweets? What would you do differently when working with short documents?
Very good question. BERTopic is really bad with short texts. So definitely Top2vec works quite well with short text, BERTopic doesn't. So you saw I had long text and it still created a massive outlier class with, so it clearly states, I think even in the documentation, that BERTopic doesn't work really well with short tweets. So I would try Top2vec, but I'll honestly say I have worked with tweets a lot, but not in a topic modeling context. So what I would recommend, what a lot of people don't know, and I will admit I found out way later than I want to admit, is that if you use something where you need pre-processing, for example, let's say you use Top2vec without embeddings, you need to tokenize tweets very differently than the normal documents. And NLTK actually has a tweet tokenizer, which I only found out like literally towards the end of my PhD. I wished I had known that earlier. So for example, normal tokenization would either maybe scikit-learn, by the way, also, if you ever use, it's just a lot of extra knowledge now for you, so take notes. So the way that, so if you use scikit-learn to vectorize, so if you use a bag of words approach, by the way, nothing bad with a bag of words approach if your data is not really complex. If you use count or TF-IDF vectorizer from scikit-learn, you please go into the documentation and check out the parameters, because by default it deletes numbers, it deletes, what do you call it? Punctuation, it deletes punctuation, and it deletes all words that are shorter than 3 letters. So you need to actually define a regex to tell the vectorizers to not delete that. So obviously for tweets, that's a massive issue. So that was regarding scikit-learn. And regarding tweet tokenization, so if you use just normal word tokenize in NLTK, it will maybe not that relevant these days anymore because now we're using emojis, but still, a couple of years ago, people would just write a smiley, right, which are the colon and the bracket, and that would get tokenized, but actually that you want to keep together. Same with hashtags, right? You want to keep like hashtags and mentions and stuff together. So yeah, check out Tweet Tokenizer. It is in the NLTK library.
Okay, so next question. This one's from Chris. What are the inputs for the classification task?
The vectors of the, sorry, the inputs of
inputs for the classification task.
Yeah, so the vectorized documents using bag of word. So because you see those are all non-deep learning methods, so it was just using a bag of word approach. So the sparse vectors for each word in the document.
Okay, then, yes, next question. How to handle freshly emerging, previously unseen topics?
That's a good question. Yeah, then you would need to retrain, right? If you, so first, so again, what I would do is I get a new policy document, let's say in this case, and if I see, and then you check where it ends up in the model, right? You feed it into the model and then you check in which topic it ends up. And then if you see that the document is like completely different to, to all the other documents in that topic, oops, probably you have a new topic, maybe worth retraining the model. Although I wouldn't risk it just with one single document. That might actually just be an outlier. But of course, if you deal with like some, let's say you wait for a year, the market has changed, whatever has changed, whatever project/corpora you're working with, then obviously you need to retrain the model so that this new topic is somehow captured by the model.
Okay, so could the BERT model used by BERTopic be used as a classifier for new documents?
The what? Sorry, can you repeat that?
Could the BERT model used by BERTopic be used as a classifier for new documents?
I mean, BERTopic is not a classifier, so there is no classification within BERTopic. But as I said, so this is what I've done here, right? Like you create the topics, these are used as labels for your documents, and then you can train whatever classifier you want, right? Also more advanced ones. As I said, I just want to quickly do something out of the box, so this is why I use the scikit-learn ones, but obviously you could also take BERTopic, or even freaking LDA, doesn't matter. You just need the labels, right? And then you can build some super fancy unsupervised, some fancy deep learning model and actually use embeddings of the documents and not like I did here, bag of word approach. But BERTopic or any of those topic models, you need to create the labels because they're unlabeled.
Okay, so Sabina asks, what measures can you use to define how distinguishable topics are?
That's a good point, and I will honestly say I didn't look into those measures. There are measures to check like topic coherency and things like that. I decided not to do it, first of all, because time. Like, I really don't want to sit down in Bali and analyze 50 topics and a topic coherence, I'm sorry. So this is why I created those use cases and was like, if any of you wants to actually evaluate those models from a research perspective, feel free to do so. I actually wanted to do something, also because this is not an academic conference. In an academic conference, I would have probably chosen exactly that approach. I would have analyzed for topic coherence, and like how clean they are and things like that. But because most of you guys, apart from very few exceptions in this room, work in industry and not in research, I was like, probably you guys will benefit more if I define industry use cases instead of checking like how coherent topics are. So I'll leave that up to you. Whoever asks that question, you can do it.
Okay, so the next one. What happens in DTM if the topic disappears? Will the model start filling that class with the closest document to that topic?
That's a good question. Well, first of all, okay, what do you mean with disappear? The topic can't disappear. The model was already trained, so that topic is there. Right? But again, so similar to the question a couple of minutes ago, if you believe that like time has moved on and there are new topics, you need to retrain the model. Or if a topic disappears in the new model, well, then so it. But this model is already trained. A topic can't disappear. A topic like the frequency can drop, as you can actually see here, right? Like the frequency for some topics drops to 0. So in that year, that topic wasn't mentioned, right? But it can't disappear from the model.
Okay, so one more from Chris. How do you recommend manually evaluating topics with human annotators?
Okay, I would not do it with annotators, right? I would use it like so what we did with my boss. It was literally just a team of 3, and only him and me. We were coders. We would literally just like look at the documents that ended up in one cluster and decide whether it makes sense or not. Like I would not hire a huge team of annotators and be like, I don't know, because like what is there to annotate? Because then we're kind of like killing the whole purpose of topic modeling. If you have the funds to get annotators, well, then give it to them, right? And don't bother with an unsupervised method. So once you've already done that, either hire an industry expert, but most likely you are already the industry expert. It's your data set that you're interested in, and then I would just deep dive into the topics and actually analyze them, whether they make sense. Okay, so the next one. Do you have thoughts on topic modeling with image video data instead of text? No, I absolutely don't know anything about imaging. I'm an NLP person only. The only thing I've ever done was the MNIST one with the... That's the only thing I ever did using scikit-learn. So with imaging, please not. That's not my area of expertise. Okay, we still have some questions. Well, we still have some time, so yeah. Hau raus. Did you use n-grams? Should you for Top2vec and BERTopic and LDA? N-grams. So an LDA, no. I used n-grams of size 1. I just used individual words. Top2vec, no, but you can. Actually, very good point. You can use phrases in Top2vec. So again, feel free to experiment. And in BERTopic, because it's embeddings, there's no need for n-grams because you use the whole embedding. But yeah, good point. If you use a bag of word model, of course you can use n-grams. And yeah, again, you'll need to experiment. I personally didn't, but yeah, good point. So Top2vec supports that. Okay, so we continue. Do you think LLMs could outperform the presented methods? What can outperform the presented method? LLMs, large language models could outperform. I don't know. I haven't tried. So
The blocks of texts are small parts of the original PDF in the Breezebook study.
Yes.
Breezebook study.
Okay, yeah, in the data set. Yes, yeah. The documents were split in paragraphs.
Cool. So, 3 more.
I mean, come on. It's 40 documents, and we end up with 14,000 blocks of text. Would be a bit weird. The math doesn't add up, right? So yes, that was split.
So yeah, we have 3 more questions and some time. So if you still have questions, you can still add. Have you done topic modeling on multilingual data? Any insights or advice when doing so?
No, I didn't. So as I said, I did a legal tech project, which is obviously all in English. With very few exceptions for some reason, Welsh and Scottish. But and as I said, I used Top2vec, so language wasn't really captured anyway. Well, using Top2vec. Although I did also use embeddings back then, not for this project, but for the previous one. Can't remember what happened with the Welsh and the Scottish documents. Probably they all ended up in one cluster. And so no, I didn't. And as I said, for LDA, that won't work anyway. Well, no, actually, it would. It's just that because bag of word is language neutral, right? It's just like, it doesn't matter whether something is written in Cyrillic or in English. It's just a completely different token. So sure, you can absolutely use LDA on multilingual data. And for BERTopic, yeah, you'll have just to check out one of the multilingual models from Hugging Face and plug it in and see what comes out of it.
Okay, so for the processing, why did you not merge smaller topics into bigger one for the LDA?
Well, because for LDA, you choose the topics anyway, and I chose, what was it? And I chose either very small numbers. So for, like, again, we're dealing with 14,000 documents. So LDA 3, we end up with topics that contain over 1,000 documents. And even in LDA 50, there wasn't, because 50 was hard-coded, right? It was predefined. There were no topics which were really small, whereas for Top2vec and BERTopic there were.
Great, so do you have any tips on dealing with documents that may contain multiple topics?
Well, first of all, we never know, like, many of those documents might have actually contained several topics, right? It's, again, something that I can't check in 14,000 documents. So what I would do then in this case, right? So this is what kind of use case 1 is about. So unfortunately, I don't have a, I should have had a visualization. Okay, so I'll show it with my hands. So let's say you have this topic A, yeah? And there are like documents inside topic A, right? But let's say that one of the documents is kind of located here at the very outskirts of topic A. Yeah, and then you have topic B here. So actually something from topic B might be actually closer to that document, right? So this is why, like, you can use the topic labels, you know, like labels from 1 to 50, or you can actually just check for similarity. And then maybe actually for a new document, which would have maybe ended up in topic A, if you check for similarity, also a bit like KNN, right? So also like documents which surround it in the surrounding topics would also be extracted using a similarity score. So this is how I would, and then you can kind of also base, you can set some kind of threshold, and maybe based on this threshold, you could even assign several topics to a document.
Okay, then. What encoder model is behind BERTopic when you used it, Roberta, or did you test the new modern BERT?
I didn't use Roberta. I just used the default one, which is sentence BERT.
Okay, then the last question: which method would you apply on text data containing unordered, unrelated terms? Would you expect some benefits from Top2vec or BERTopic?
Text where the terms are unrelated. Say it again.
Unordered, unrelated terms. Text data containing unordered, unrelated terms.
Well, then you can try LDA, you know? Like, well, because if there is no actual human, do you understand correctly? So that it's just random terms, so it doesn't actually, so it doesn't form a human sentence. Well, then actually the word order doesn't really matter, right? So then you could even try LDA. Well, yeah, or Top2vec, then actually using BERTopic might not be the best idea because we kind of assume that it's a human readable language. if I understood the question correctly.
Okay, then, yeah, I think we answered all the questions in
we're right
perfect
on time.
timing.
Perfect.
Thank
as
you, Lisa.
usual. Thank you.